Hello, and welcome to the Quality Assurance Quality Control portion of the workshop. In this section, we will discuss some quality checks you can perform on your data once you feel they are ready to submit to OBIS. This section is intended to be a precursor to the automated checks OBIS performs on the data it receives. Really, what we're trying to do here is limit the number of iterations you might have with an OBIS node manager to rectify minor issues with your data during the submission process. Ideally, we're providing a few tools so that you can assess any adjustments that might need to be made prior to data submission. So for reference, linked in the description of this section is a publication of the QC checks that OBIS performs on the data, which you can see here. Below, we'll walk through a couple good checks to perform before we get to loading these data into OBIS. What we're really trying to do here is identify any outliers or faulty data points. So there's numerous tools that you can use to review your data for these outliers or faulty data points. So for example, R has numerous functions within the OBIS tools package. They can help you identify any values that might need to be reviewed. Also, Python has various packages that can be used to do these checks as well. So for now, we'll dig into what we should be looking for in terms of outliers or faulty data points. So some initial recommended checks to perform on your data. First and foremost, you should check that all the required Darwin core terms are present and contain the correct information. So this links back to the introduction of that required Darwin core terms table. Next, you should make a map of your data to ensure their coordinates are valid and within your expected range. This usually helps identify any issues with latitudes and longitudes. Next, you should run some basic statistics on each column of numeric data to identify any potential issues. So min, max, mean, standard deviation. This will help you identify if any of the numerical values are outside of the ranges you expect. Next, you should look at the unique values of columns containing string entries to identify any potential issues. So this tends to highlight any misspellings or any kind of issues with string entries. You also want to check the uniqueness of the occurrence ID field. So for each occurrence, you should have a unique occurrence ID. And you want to go through and make sure that each row has a unique identifier for that occurrence. If you're using the event core, you want to make sure that each event has a unique ID and making sure that they match up to any occurrences or anything like that. So checking for the uniqueness of event ID. And you should also check that the dates are following the ISO 8601 convention, as this is the standard for Darwin Core. And lastly, you should check that your scientific name IDs are valid. And even if you used a programmatic way to collect these scientific name IDs, it's always good to go back and check and make sure that your scientific name is matching to the scientific name ID that you identified earlier. So one of the a really nice tool that R provides is the HMISC describe function. And what this does is it really summarizes a data table, and it gives it in a nice printout so you can actually get a quick summary of your data table and find some of these outliers. And so what we have here is just an example of using R to bring in a data file and use that describe function. And you can see below where it gives you a nice summary of how many values you have, how many unique values, what are some example entries in that table, and so on. So this is a really nice tool to get an initial summary of your data set. Python has a similar package using pandas. There's a describe function, and that'll give you a similar output if you're interested in using Python. So next we have an exercise where we actually walk through bringing in an example data file and running it through the checks in R and then doing the same checks in Python. And so in R, we walk through using the checks and using the OBIS tools package, where we get a nice printout, and then we also get some good summary information. So these are doing a lot of those checks above using the OBIS tools package. And then the next one, we have it in Python, while OBIS tools doesn't exist for Python, we can use other packages like pandas, cartopy, and geopandas to perform similar types of checks. And so here's just some code to do those types of checks and give a similar printout of what we had above with the R package. So those are some examples you can do for R and Python to perform these checks. And then lastly, we'll want to make sure that the values that you have in each column are actually representing the entity you want to be reporting. So we have an example of individual count, and individual counts should be whole numbers as integers because you're representing a unique individual. And so one of the checks an OBIS node manager might do is look at that column and see if there's any non-integers or float values. And if there are float values, then they'll have to iterate. So it's good to check and make sure that your values actually make sense. And that's it for this section. So if you have any questions, feel free to reach out to any of the helpers during the workshop. Um, Thank you.